Alright, section 1.3 of Stewart's Calculus, 7th edition, early Transcendentals, and today we're talking about composite functions, yay! So in the last video I talked about multiple operations you can do with functions, and now, and I introduced notation like this, f plus g of x. And that was f of x, basically f of x plus g of x. And I'm going to introduce a new notation, f little o of g of x. And what this is equivalent to is f of g of x. So these two are exactly the same thing, and they mean the same thing, but what is that? What does that mean? Well, that means that the argument, we're going to start with g of x. The argument of g of x is x. And whatever that is, that result is the argument of f of x. So you could think of it as, here, let me rewrite it with colors. So here we have f of x, and here we have g of x, and we have x. That's too close. We have x. Okay, f of x is our outside function, and g of x is our inside function. Alright, and x is our starting argument. I'm just going to put argument. So when we're writing composite functions like this, we need to be given f of x, and we need to be given g of x. And then we'll be given an x eventually to evaluate the composite function f of g of x. So let's just say f of x is equal to square root x. Make it simple. And we'll also say that g of x is equal to x cubed minus 4. Why not? Alright. So now what would, for example, let's do some examples. What would f of g of x look like? And then what would, number 2, what would g of f of x look like? Notice I'm using two different notation. So, like I said, we're always going to start with the inner function, the inside function. So in this case, g of x, and I'm going to write it like that, just in space. And then we're going to put this g of x into the argument of f of x. So wherever x is in f of x, we replace that with g of x. So what we're going to have is this. Notice this is f of x, and you could think of these parentheses, making a group here. You could think of this as the x in f of x. Alright, you could think of it like that. So this is actually equal to f of g of x. What about g of f of x? Well, we're going to start with our innermost function, so root x. And now, since f of x is being written inside of g of x, every instance of x and g of x must be replaced with whatever f of x is equal to. So you could think of the parentheses again as being the x of g of x, like that, and we're going to cube the x, and we're going to subtract 4. Okay? It's not too hard a concept, at least it shouldn't be. You will also do things like, you also have to do things involving composite functions with recognizing certain functions. So for example, if I have 2 plus quantity 9 minus x squared cubed, and that was equal to f of g of x, what would f of x be and what would g of x be? Okay, well, Now see, I could think of, well, one really prominent f of x could be f of x, since it's the outside function, we could think of this parentheses as being the quantity x of g of x, the inner function. Actually, I'm sorry, we could think of it as being g of x, the inner function. So f of x could very well be 2 minus x cubed, right? And then this x would be this, and g of x would be 9 minus x squared. And recognizing composite functions is important, especially when we get to chain rule later on in our studies of calculus.